Today, in this video, we are going to discuss about the chapter Laws of Motion. It's a chapter in grade 11 syllabus CBSE. This chapter, we are going to analyze the most important concepts and equations as the preparation for Neet or JEE. It will be helpful for you in the side preparation also. We can see what are the important terms of this chapter first of all. One of the initial topic of this chapter is the term inertia. Inertia is nothing but is the ability of any material, any object to continue in the state of rest or of uniform motion. That means if a body is at rest, it like to be or it want to be remain at rest continuously unless if you apply a force on it. This tendency of a body to remain in its state, that means either rest or of motion, is known as inertia. This inertia can have three types actually. So based on inertia level questions, we can expect in the exam also. There is no equation based calculation for this purpose, but the concept wise. You know, when you shake the branches of a mango tree, the mangoes fall down. It is due to inertia of rest. How to implement this topic, this concept there means actually, the branch and the mangoes were at rest initially. When we applied the force on the branches came to motion, but the mangoes want to be at rest because of the inertia of rest. So they detach themselves and they fall down. Now when you travel in a bus, you're standing. So when the bus suddenly stops, we have a tendency to fall forward. It is because our body have the inertia of motion. We, with the bus platform, we were in the motion. So when bus came to stop, our upper part of the body want to be in motion because of inertia. This is an example for inertia of motion. Like that many examples you can say. But inertia of direction is the tendency of a body to remain in the state of the same direction, to follow its direction. Inertia of direction. You know, on the wheels of a vehicle, the muds, it just detached from the tire in a straight line. The mud guard stops it. So on the rotation, it just go along the tangent of the circle. We can say the mud guard stops it. These all are some examples for inertia level problems. Now, inertia is higher for heavier objects and lower for lighter bodies. So we can say in one sense, the inertia is measure of mass of a body also. Heavier the object, higher will be the inertia, or the more tendency will be there to remain in the state of the motion or the rest. The lighter the body, it will be least tendency to be in rest or in motion, or it is easier to change the state. From this concept of inertia, we have the first law of motion. It's also known as law of inertia. That means to change the inertia of a body, or every object will continue in state of rest or of uniform motion unless an external force is unbalanced force is acting on it. That's the concept of first law of motion. A numerical level concept not into there be actually the base of the theory you should know about it. Inertia and first law of motion. Now when we come to the second law of motion, it says about momentum of a body. Momentum is a product of mass and velocity of a body. It is a measure of total movement, the motion in a body. We can say mass and velocity is a vector quantity. So since velocity is a vector, the momentum is also a vector quantity. It has the SI unit kilogram meter per second, the unit of the momentum. So a heavier body have higher momentum since its mass is very higher. A fast moving truck has again higher than momentum because both mass and velocity is higher. So it's a product of mass and velocity gives you the quantity which gives a measure of motion in a body. This momentum and force are related as given by the second law of motion. Second law of motion says that the external force acting on a body is the rate of change of linear momentum of the body. It is directly proportional to each other. So as the higher force you apply on the body, its rate of change of the linear momentum will be higher. Momentum is P. If you just differentiate dP by dt, you can have it m into a, the acceleration. This is a famous equation for the force to calculate F equal to ma. This you are getting from Newton's second law of motion. F equal to ma. That comes from this way. Momentum is m into v, so m into dv by dt. So in some cases, this force acting on the objects may vary in two ways. One, either by varying the speed of the body or varying the mass of the body. In two ways, a force can be experienced by a body. Normal case, if you kick a football in the forward direction, its mass will be constant, but its velocity may change. That means the body may get accelerated. That is because of the force. Then you can use the equation F is equal to m into dv by dt. Mass of the ball and dv by dt, rate of change of velocity. That is nothing but acceleration of the ball. And in the case of a rocket may move with constant speed, but its mass get reduced because of the thrust acting on the rocket. That F you can write as negative of v dm by dt. Rate of change of mass with respect to time will be given. Or a conveyor belt moving with objects. So objects are just removed from it, but the belt moves with constant speed. We can use the same equation there also. No need of negative there. If you represent the thrust of the rocket, then F is equal to minus v dm by dt. In both cases, the unit is Newton, the SI unit, or kilogram meter per second square. If force is external force acting is zero, we'll say the body is isolated. There is no external force acting on a body. Then the total linear momentum of the object will be constant. That will call it as conservation of linear momentum. If F is zero, then P is constant. Conservation of momentum says that the body will be in an equilibrium state. Mass and velocity will be constant always. And can obtained by velocity will be constant throughout the motion, which we can get the first law from second law. So conservation of linear momentum is based on the external force is zero. Means for an isolated system of particles, the total linear momentum remains constant. So to change the linear momentum, there should be an external force. If there is no external force, total linear momentum remains constant. We can get this concept from second law of motion itself. Now, this second law can be updated to another level we call as third law of motion. Always the force experienced or acts in a pair. For every action, there is always an equal and opposite reaction will be there, as given by the third law of motion. From third law, we can have the conservation law also. By that, one example is the recoil velocity of gun. When a gun is triggered to push a bullet forward, a gun applies the force on the bullet, so the bullet moves forward. Same time, the bullet will apply a force on the gun, so gun moves backward. We call as recoiling of gun. Same thing happens in the rocket also. Rocket propulsion, the rocket fuel chamber, the fuel is ejected down. By burning, fuel is ejected down, so the rocket gets a pull upward. Action and reaction. So for every action, there is always an equal and opposite reaction. This is given by the third law of motion. Isaac Newton says that always force acts in pair. These both forces are not acting on the same body, on the different bodies. First body applies a force on the second, that we can call as action, and the second body same time applies a force on the backward, that can be called as reaction. So these two will not get cancelled. Okay, from this concept we can get the recoil velocity of gun V is equal to negative mv divided by m, capital M. This m is the mass of the gun and small m stands for mass of the bullet, and v is the velocity of the bullet. The negative sign shows that velocity of gun will be in the opposite direction of bullet, velocity of the bullet. This concept we get from second law and the third law. From second law, one more thing we can get a term called impulsive force or impulse simply. Impulse I is equal to force into time duration, F into delta t. How much time the force is acting on the body? The time into force, product of force and time gives you the impulse. It is nothing but will be equal to change in momentum, because this F is equal to delta P by delta T. Change in momentum by time taken. So F into delta T will be the change in momentum. So momentum change will be equal to impulse acting on the body, or simply we call as a greater force acting on the shorter level of time. We call as impulsive force. Many examples you can say. When you are hammering a nail, The hammer applies a great force on the nail for a short time. So there will be an impulsive force acting on the hammer on the nail. So hammer acts a great force on the nail. It's an example for impulsive force we can say. So these are concepts we can get from the concept of force. Now, once you come to the practical life, motion of a lift is an example for force problems. When you're standing on a lift, if lift is accelerated upward or downward or moving with constant speed, that means without any acceleration, what you will feel? Sometimes you will feel weighter, heavier, sometimes you will feel weightlessness. These two concepts can happen. How to calculate the apparent weight, that what the felt weight will be. For that we can have, these problems can come across. In a lift, you're standing, your weight is mg downward. Then if it is moving upward with an acceleration a, if the lift is accelerated upward, then the apparent weight you feel r dash is equal to m into g plus a, where g is acceleration due to gravity. You can take as 10 meters per second square or 9.8. So this, if you should add up the acceleration, so you'll feel more weight, heavier you will feel. Now, if the lift is coming downward with acceleration a, then your weight will be m into g minus a. That means you feel less weight, lighter you will feel. Now, if the thread with which the lift is hanged is broken, then the lift will fall with the acceleration due to gravity. Then you will feel zero weight. A will become g, so m into g minus g. That means apparent weight will be zero. You will feel weightlessness. If the lift is moving up or down with constant velocity, means it's not accelerated, then you will feel your normal weight r dash will be equal to mg itself. Your actual weight will be felt. So a lift problem can come across in this chapter to link the force acting, apparent force or apparent weight acting on a body in lift problem. The same concept you can use on a string also, a rope problem or string problem will call us, to calculate the tension of the string or rope. Suppose you climb the rope with constant speed, the tension acting will be mg. If you climb up with an acceleration a, the tension acting will be mg plus a. If you climb down with an acceleration a, the tension acting one will be mg minus a. So either rope problem or lift problem, both you can use these concepts. So please note down, this is important. Now, on a body, there are three forces acting, like this one, problem F1, F2, F3. By making the angles between alpha, beta and gamma, then Lami's theorem gives you a chance to solve these forces if you know any of these three, either the angles or the two forces. F1 by sine alpha will be equal to F2 by sine beta is equal to F3 by sine gamma. They give you the concept how to resolve the forces if more than one force acting on a point. Now, if two forces are there, we can use normal parallelogram law of vector addition also. If they are making an angle theta there, then we can use this resultant of forces will be equal to root of F1 square plus F2 square plus 2F1 F2 cos theta. The cosine law says about it. Suppose there are two forces, one force acting like this way, another force acting suppose this way by making an angle theta there. Then you can use this same equation. We are getting from parallelogram law of vector addition. We get the two numerical questions regarding this. A question is like this way. A certain force gives an object of mass m1 an acceleration of 12 meter per second square and an object of mass m2 an acceleration of 3 meter per second square. What acceleration would the force give to an object of mass m2 minus m1? This force is regarding second of motion, F is equal to ma. We can see how to solve it. So here is given acceleration a1 is equal to 12 meter per second square and acceleration a2 is equal to 3 meter per second square. Now, in this case, what is the acceleration would this force give to an object of mass m2 minus m1? So for mass m2 minus m1, what will be the acceleration applied by the same force is the question. So you have to find each acceleration is given and each mass you can find out. So m1 I can write as f by a1, that is nothing but f by 12 M2 you can have it F by A2, that is nothing but F by 3. The same force acting on both bodies. Now M2 minus M1, what will be? M2 minus M1 is a total force. When the given resultant mass is given M2 minus M1, so if you do it, it will become F by 3 minus F by 12. So this is nothing but 12. The LCM you can take it. If you cross multiply it, 4F minus F, so that is 3F by 12. That is equal to F by 4. So M2 minus M1 is equal to F by 4. Now the acceleration, resultant acceleration is equal to force by mass M2 minus M1. So that is equal to F by M2 minus M1. So F by 4. That is nothing but 4 meter per second square. So the option is D, 4 meter per second square. We can see one more question. A mass of 1 kilogram is suspended by means of a thread. The system is lifted up with an acceleration of 4.9 meter per second square to lowered with an acceleration of 4.9 meter per second square. The ratio of tension in the first and second case is a question. So a mass of 1 kilogram is suspended by a wing of a thread. So a thread is there a mass M is suspended. It is 1 kilogram. So here mass is given 1 kilogram and G I am taking 10 meter per second square. We can take it for calculation easiness. And it says that when the mass is lifted up an acceleration of 4.9 meter per second square, at that end, what will be the total tension? I am putting T1 it is equal to M into G plus A. Just we discussed that the resultant tension or the apparent tension will be M into G plus A. And when it is downward, it is lowered with an acceleration of 4.9 meter per second square. In the second case, in that case, T2 will be equal to M into G minus A. And the question is, you have to find the ratio of tension in first and second case. So T1 by T2 you have to find out is equal to M cancels G plus A by G minus A. That is equal to 10 plus G's are 4.9 divided by 10 minus 4.9. That is equal to 14.9 divided by 10 minus 4.9, it is 5.1. So this will become as 3 by 1, 3:1 almost. So T2 by T1 make it. So here the concept is lifting or lowering of this rope. How to make it? So T1 and T2, mg plus A while going upward, while lowering it mg minus A. I hope you got these two questions. Another important topic of this chapter is friction. What is friction? We know that friction is actually an opposing force acting against the relative motion of a surface on another. Suppose two surfaces trying to move relatively, then the force acting opposite to the movement, the forward motion, is termed as friction. This friction is mainly three types: static friction, kinetic friction and rolling friction. So three ways we can have it: static, kinetic and rolling. The static friction is the friction acting between two surfaces at rest when one trying to move on another. Is not actually moving. That's called static friction. It's a self-adjusting force actually. As soon as you try to move but the body is not moving, the friction force also increases. And the maximum value of static friction we call as limiting friction. Limiting static friction we can call as. The theory, this law says that the limiting static friction is directly proportional to the normal reaction force. From there, you get actually Fs is equal to a constant into reaction force R. This constant is called a coefficient of static friction, mu s. This coefficient everywhere regarding friction will make use of. Then next friction comes kinetic friction. When a body slides over on another surface, then the friction acting is called kinetic friction. And when one body rolls over another surface, the friction is called a rolling friction. Of course, in the practical life, we can know the rolling friction is the least friction acting. There, the body is very easy to move it. When a horse pull its truck forward, before starting, it have to apply more force because at that time static friction is there. Once the pull cord is started to move, then it have to roll. It is rolling, then it have to apply less force only to pull it forward. Anything like that only. Suppose a car is at rest, you try to push it. It's very hard to push it. But when the car slightly started to move, then it's easy to push because rolling friction is there. That's the magnitude of the forces. Now, in this topic, some numerical ways, some important terms are there that we have to come across it. One of the terms is angle of friction. This theta is given by tan inverse mu s, the inverse tangent of coefficient of static friction, tan inverse mu s. What is angle of friction? It is actually the angle between the resultant of static friction and the normal reaction which makes with the normal reaction. And the angle of repose, alpha is equal to tan inverse mu s. It is this angle in an inclined plane when a body just starts to slide over the plane. The angle made the inclined plane is called angle of repose. Is given by tan inverse mu s. Numerically, both are equal. Angle of friction is equal to angle of repose. Now, in this friction concept, this item, inclined plane, is have a crucial role. In the numerical questions, you can expect it. By using a free body diagram, we can resolve. Suppose a body is on an inclined plane. Is of mass m, is the mass. This body, when you just make the plane inclined so that the body just start to slide over it, then this angle is called angle of repose. And when it's moving, just started at equilibrium, just started only at equilibrium. If you resolve the total forces acting on the body, then we get a figure like this way. We call as free body diagram. Its weight will be downward mg. If you resolve mg to two parts, mg cos theta and mg sin theta, you will get. The reaction force is perpendicular to the surface upward, and against the downward motion, there will be friction force F, upward direction. So these are the forces acting on the body. Now, this acceleration A is given by, if you resolve the forces, this A, the acceleration, resultant acceleration, means if you just resolve the forces acting on it, then resultant action A is equal to G into sin theta minus mu cos theta. But this theta is the angle of repose. Mu is the coefficient of friction. So by using that, acceleration get as a resolution, and the resultant forces, if you just resolve it, you are getting this concept. These ideas on inclined plane, we can make use on another concept also. In a banked road, if a body trying to move in a circular road actually. The circular road can be a plane also or a banked one also. In both cases, what will be the maximum speed of the body, a vehicle, car suppose, where you can use this concept actually. So when there one more force will come, there was centripetal force, F is equal to mv square by r, where r is the radius of the circular turn I was taking. At that time, if a cyclist is trained to move along a bend, the cyclist have to bend through an angle for a safe drive. Otherwise, he will slip out of the curve. The angle is given by tan theta is equal to v squared by rg. From there, you can get the maximum speed there. V is equal to root of tan theta into rg. The maximum speed can be. The cyclist can take it around it. Now, if a car on a level road is moving with the friction mu, if we consider, then V max is equal to root of mu rg. R is the radius, G is the acceleration due to gravity. And if it is banked road is there, you know what is a banked road? One edge of the road is up by banking is called banked road. So it will be level road on curve. To get sharp turns, we come across the banked road. The maximum speed depends upon the angle of banking or the angle of repose also. This is an angle of banking, we can say. Angle of repose. And the friction also. So coefficient of friction. We can get V max is equal to Rg into mu plus tan theta divided by 1 minus mu tan theta all power 1 by 2. So square root. So by using this equation, you can get the maximum speed. Without slipping, how to move? That's a safe speed, we can say, the maximum speed. If the body overcomes this speed, the vehicle will overturn on the curve. So for safety, this is the maximum limit, speed limit, we can say. So this is about the friction topic, what I come across this chapter. So please take care about these ideas. Now, one another common questions we can expect from this chapter is regarding pulleys. You know, pulley is a mechanical device or arrangement which easifies your movement. Pulley we call as. So connected pulleys also, individual pulleys also. Some of the two major concepts is one vertical pulley and one horizontal pulley problems. Suppose two bodies M1 and M2 are supported with thread, frictionless, massless, like thread is kept along a pulley is kept like this way. Suppose M1 is greater than M2, so M1 will try to pull it down with an acceleration A, some tension T, and M2 is moving up with an acceleration A. Then the resultant acceleration of these masses will be M1 minus M2 by M1 plus M2 into G. This is the acceleration of the body which is moving down. And the tension acting will be 2M1 M2 by M1 plus M2 into G. So in vertical cases, this is ideal credit. Now instead of vertical concept, suppose on the horizontal plane, a body is kept of mass M1 attached to the string and is allowed through a pulley with another mass M2. Suppose M2 is bigger than M1, so it will pull down. Then here acceleration is given by M2G divided by M1 plus M2. From vertical, only M2 are considered here. And tension is given M1 M2 by M1 plus M2 into G. So these equations also you will take care regarding the pulley. Now we can check one numerical problem regarding these ideas. So I hope these topics you got it is very important. A question is like this way. A small block of mass 0.1 kilogram lies on a fixed inclined plane PQ, which makes an angle theta with the horizontal. A horizontal force of 1 Newton acts on the block through its center of mass as shown in the figure. The block remains stationary if 4 options are there. The G can take as 10 meter per second square and 4 options A, B, C is given. When theta is equal to 45 degree or theta is greater than 45 degree and friction force acts on the block towards P, C and D, like that options are given. We can check how to resolve the forces. This is the inclined plane and an angle theta is inclined. Now here is the object. Here a force F is acting like this way and its mass is downward, so mg you can say is downward. So if it is theta, then you can resolve this mg to two parts. This theta will be, so this will be mg cos theta and this will be mg sin theta. The free body diagram, this way you can make it. Now this F also you can resolve into two components. So this will be theta again. If it is theta, this is also theta again. So this will be F cos theta and this will be F sin theta. And this will be the normal reaction force acting on the body. So I hope you go to how to resolve the body into different forces. So here the question is actually the body will remain in stationary. Then what should be the theta? That's better find out actually. Okay, so here now to be stationary, that means this total net force acting on the body should be 0. For that purpose, from the figure it's very clear that downward force is mg sin theta and upward force is f cos theta. Both should be equal. So we can write f sin theta is equal to f cos theta is equal to mg sin theta. If you just resolve into sin theta by cos theta is equal to f by mg. Sin theta by cos theta is nothing but it is tan theta. That is equal to f by mg. So it's given here and our horizontal force 1 Newton is acting on this block through its center of mass as shown in the figure. Okay, so here this tan theta is equal to nothing but f by mg, that is mu. Mu is equal to f tan theta we get it. Now this tan theta is equal to 1 only, so theta is equal to 45 degree. So here theta is 45 degree. Now see the question. In these options, if you go through it, we can see the options like this way. Theta is equal to 45 degree. Of course we got it. So option A is correct. Don't go hurry to make it answer A. Now B also you check it. Theta greater than 45 degree and a frictional force acts on the block towards P. So towards P means downward. Downward there is no friction force. Only friction force we have upward. So this is P and this is Q and this is O. That's given in the figure. So towards P there is no friction force acting. So B is wrong. Now C is there. Theta is greater than 45 degree and the friction force acts on the block towards Q. So towards Q the friction force is acting. That is correct again. So force is 45 degree also and force is there. So option is D. Both A and C are correct here in this question. So I hope you got to how to resolve this one and concepts. Now we can check another question. Question is like this way. A 100 kilogram gun fires a ball of 1 kilogram horizontally from a cliff of height 500 meter. It falls on the ground at a distance of 400 meter from the bottom of the cliff. Find the recoil velocity of the gun. G you can take 10, then 4 options are given. We can check how to resolve it. So according to the figure, a gun fires a ball horizontally from a cliff of height 500 meter. So there is a cliff of height 500 meters, the vertical height. From here horizontally is gun fires it. So this is the initial velocity ux. So that the ball falls in the bottom at a distance of 400 meters. The mass of the gun is given 100 kilogram. So mass of the gun, capital M I am putting 100 kg is given. And the mass of the ball is given small m, I am putting 1 kg. Mass of the ball. Now these are the functions. You have to find the recoil velocity of the gun. You have to find out. So recoil velocity, the equation just we got it earlier. V is equal to negative m into v by capital M. So this v is actually mass velocity of the bullet, actually initial velocity of the bullet. So here I am putting it as ux. I am putting. So m ux by capital M is the recoil velocity. You have to find what is ux. For this purpose, we can make use of equations of motion also. We have the equations of motion s equal to ut plus half a t square. We can resolve the two components, one vertical and one horizontal. In vertical direction, x is nothing but 500 meters. Vertical displacement is equal to vertical direction u, it is 0 only. So half g is 10 into t square. So here from here you can get the t, time taken. So if you take this will become as 5. So t square is equal to 100 or t is equal to 10 seconds. So it takes 10 seconds to come down. Then in horizontal concepts, you can take this concept as (400 meter travels and horizontal velocity is ux. Actually that ux you have to find out to substitute here. So ux into t is 10 seconds plus half into g is 10 into t square, 10 square. So if you substitute this ux, you can get it is equal to 40 meter per second. Ux is equal to. So if you substitute in this velocity, then you will get v is equal to m into ux by capital M. So you will get that value as v is equal to m into ux by m, that is 1 into ux is 40 divided by capital M is 100. So its answer is 0.4 meter per second in the magnitude, and direction will be opposite. So I have got your answer. So here the basically how to resolve this initial velocity, the velocity, then two concepts. You find the initial velocity of the bullet, the horizontal velocity. I hope you understood it. Thank you for watching. See you.
Bright Education Center, Medical and Engineering Entrance Coaching Center, Hilal area, Doha, Qatar. For further enquiries, contact 306 00679.